My friends, this is SHYSKY. In this video, I will briefly display the water pumping performance and a lot of protection performance regarding SHYSKY DC60D-24120A model. Okay, it is this with adjustable pump that is placed here. This is the pump body part with both inlet and outlet being with external diameters of about 20 millimeters, 2 centimeters. Not threading. Let's get it closer. Yeah, inlet and outlet. This is the pump body part. This is the control box part. Control box includes the main control and protect circuits being sealed within. So we call it the brain part of the whole pump. And then this is the potentiometer knob, which we as users can adjust the power and flow when the pump works in the system, rather flexible to fit the various parameters demands in the water handling system. Yeah. And the other branch is the DC head connector being plugged with our external 24 volts power supply. Okay, our pump adopts the brushless DC design. So here I prepare something. Here it is the DC power supply. From left to right, it is the working current indicator. This is the power consumption indicator, and this is the output voltage. Now this output voltage is adjusted at 24.28 volts DC. Okay, because our pump is with rated voltage of 24 volts DC. And then this is a small bucket of water which is used for water pumping because it is water pump. Yeah. Okay. Now this pump body itself is completely waterproof, and when in installation, yeah, the control box part is not recommended to be placed on the water. Instead, it is suggested to be placed at somewhat dry, low temperature location. Yeah. Okay, let's place this DC60D pump under water. And then this is the control box part, and then I will use this power supply to power our pump. This is the DC head connector, DC plug-in. Now this potentiometer knob is adjusted at somewhat low power status. As we can see, now the working current is just half an amp, 0.5 amp, and the working power consumption at this moment is just 12 watts. Yeah. Let's take a look at the wake performance of this pump when its power is adjusted at 12 watts. Okay. Right, it's rather gentle, right? But not bad performance. Okay. We as users will adjust the power of this pump through rotating the potentiometer knob, and then we can view the electrical parameters to increase. We will gradually increase it to 126 watts, right? Let's inspect the water pumping performance at this moment regarding this identical pump. And we can clear the noise cast of this pump when pumping water. Okay, we can then again adjust the pump's power from higher to lower. Okay. For example, now we adjust it to the working current at 1.38 amps, and we can watch the pump's work at this moment. Now it works at the power consumption about 33.6 watts. Not bad performance at this big power level. Okay, it is about this power regulation and also the different water pumping performance Yeah. Okay, then we talk about the dry run protection. As we can see, our pump works by the high-speed rotation or impeller within to push or throw the water inflow out of the outlet of the, to achieve the performance of water pumping. So our pump cannot dry run. Now here it is dry run. That means the rotor is running with air, and in this abnormal context, the physical friction, the heat generation will be greatly intensified. And if the pump runs dry for a long time, this pump body could be damaged forever. So it is illegal situation. And we equip this pump with the external dry run protection mechanism, which means that the pump, when it pumps water, it runs continuously at high speed. But when it is in this abnormal dry run status, it will reduce the rotation speed, as we can feel it, accessing the run stop circle rather than always continuously running. This can greatly reduce the physical friction, the heat generation, but will not eliminate the side impact completely. So we as users still obliged to make sure that our water circulation system be away from the dry run abnormal status. Okay, of course, now this pump is dry run, and we place the pump back to water, let it run normally again. Continuous running and with low noise, with reliable and stable performance, right? And at this moment, the power consumption is about 34 watts, since our potentiometer knob is adjusted to a low power level. Okay, so we adjust the power to higher again. Now it is 126 watts at this moment, and the pump works at its maximum performance. In the meantime, we will talk about the constant power design when it happens that our powering voltage exceeds the rated voltage but still within certain reasonable range. For example, within 28 watts, let's inspect the power consumption's change. Normally, it will be kept almost equivalent. Let's take a look. Let's adjust the power to 25, to 28. The power consumption is almost equivalent, as we can see, right? So it will not increase when the powering voltage increases within the certain range. This is beneficial to the electrical components within, since it can offer the stable and reliable working environment to the electrical parameter electronics components within our pump's design. At 28 watts, but the power consumption is still about 120 to 130 watts. No increase, but be constant. Okay. Then we keep the power supply back to about 24. And we fill the noise class again. Watch the water pumping again. And then we stop this video about our SHYSKY DC60D-24120A, a powerful pump among our series. Thank you.